Hello everyone, welcome to Maxflex lecture series of clear aligner therapy. Following the previous material and equipment chapter, today I'm going to share the aligner chapter, how to assess aligner properties. Firstly, please allow me to briefly introduce myself. My name is Julie Li. I'm a polymer scientist with more than 20 years working experience in polymer-related industry. Currently, I work with Maxflex as R&D director. For clear aligner therapy, every patient is different. Therefore, clear aligners are customer-made orthodontic appliances. This makes assessment of their performances a quite complex task. I would like to separate the assessment of aligners into two phases. Phase 1, before and after the production, but before treatment starts. For phase 1, the assessment is mainly conducted by aligner producers. This is also the focus of today's topic. Phase 2, after the treatment starts. In other words, to assess the treatment progress and outcomes. The assessment is mainly done by orthodontists. To assess aligner properties before and after aligner is produced, the following questions need to be answered. What properties need to be tested? By using what standards or method? And how to test? The sub-rule is to follow a standard where a proper one is in place. For example, the ISO standard, STM standard, industry standard. In reality, quite often we see aligner producers also apply empirical methods for quick judgment. Some empirical methods will be shared in a short video as the last part of this topic. Now, let's have a look what typical properties can be tested and corresponding testing methods. As I mentioned previously, clear aligner are custom-made products. This means every aligner is different. Therefore, testing on an aligner is difficult. The current situation is that there are not many standards specifically on aligners to be followed. This table summarizes 3 testing standards which could be followed or referred to. Column 1 lists most important properties, such as the appearance, color and odor, thickness, fitting between aligner and dental mold, chemical properties, optical properties, stain resistance, and mechanical properties. Column 2 is an industry standard in China to test on the aligners. This focuses on the aligner properties after it's thermoformed. Column 3 is an industry standard in China to test on the dental sheet. This focuses on the sheet property before thermoforming. This gives guidance for aligner producers and orthodontists to choose a proper material for different treatment design and purpose. The last column is American Dental Association standard. Testing is done on flat sample, but after thermoforming process. Again, this sheds some light to choose a proper material for different treatment purpose. Please pay attention to the last row, mechanical property. All these 3 standards list out an important property, the 4th decay, or we call it stress relaxation. This is a key requirement for aligner treatment. I will talk more about this property later on. In the next few slides, I will briefly go through the assessment of several key properties. First, aligner thickness. Aligner thickness is important to deliver the right level of force needed. Thickness can be measured by CT or a thickness gauge. CT can also be used to measure the fitting between the aligner and the dental mold. The readings of the gap quantifies the fitting level. We can also observe with naked eyes to see whether there is any gap, insert and remove aligner from the dental mold to check whether it is too loose. In daily life, quite often patients drink beverages such as coffee, tea, wine, etc. while they wear aligners. If discoloration occurs, it negatively affects not only the aesthetic, but also other key properties as well. To measure the stain resistance, using simulation substance is a well-accepted method. We can choose different testing liquid and design the testing conditions according to the requirements. Aligners and retainers should be durable during the designed lifetime. But durability is a complex term. Any defects or failure, such as crack, breakage, warpage, permanent deformation, can lead to the needs for new aligners. Aligner breakage is one of the most common failure type complained by patients. Tear strength is one of the properties linked to breakage failure. As shown on the left, right angle tear strength indicates how much force is needed to start a crack. On the right, the trouser tear strength shows how much force is needed for a crack to grow. In both cases, single-layer and multi-layer sheets behave differently. Please note that these properties are tested in air and before usage. Mechanical property of different materials may change in oral conditions with individual habits, cleaning way, and so on. Tensile property are key parameters for polymer measured using tensile machine. This page shows a typical stress and strain curve of a polymer. From this curve, we can obtain mechanical properties such as yield stress, yield strain, tensile strength, elongation and break, and the modulus. These properties help us judge whether the material is rigid or flexible, brittle or ductile, plastic or elastic. Another key mechanical property are flexural strength and flexural modulus. These are tested also using tensile machine, but under bending mode, either 3-point bending or 4-point bending. This property tells us whether the material is rigid or soft. A higher stress is needed to bend a rigid material, but it is relatively easily to deform a softer one. In previous slides, I mentioned that stress relaxation of polymer is key for clear aligner therapy. This gives an indication that how much force can be maintained by an aligner to continue moving the teeth. The less decay, the better. This page gives an example of force decay measurement. Testing is done by using tensile machine and a dumbbell bar. The testing bar is stretched with 0.5 mm displacement in water and kept for 24 hours. The initial force and the ending force are used to calculate the force decay. This curve shows that the multi-layer The green one has a lower but much more stable force than single-layer PETG and TPU. Here is another example of stress relaxation measurement specified by ADA. Testing is done using dynamic mechanical analysis machine under a single cantilever configuration. In this test, a certain displacement is kept for 24 hours in the testing chamber with 95% humidity and 37 degrees C to mimic oral condition. The initial stress and the ending stress are used to calculate the stress relaxation. Previous two examples are tested on a flat sample, not on a linear structure. This page gives an example of 4CK measurement tested on a linear structure. Testing is done by using tensile machine with a clapping setup. A 0.5 mm clapping displacement is kept for 72 hours in air. Then, the initial force and the ending force are used to calculate the clapping force retention. The last example is an in-house operators used in our company. The aligner is assembled on a metal dental mold. The central incisor of the mold is removed so that the testing tip can apply a force on that position and result in a deformation of the aligner. The testing is done in water at 37 degrees C and lasts for several days. This curve shows that the multi-layer aligner, the green line, provides a lower but much more stable force than single-layer TPU aligner. Okay, so far I have gone through the lab testing part, following a testing standard. As the last topic, let me share some empirical way. Although no detailed reading is available, it is convenient and gives a quick judgment on the aligner properties. These empirical ways are summarized as 10 steps. Look the appearance, smell the odor, listen to the sound, using fingers to deform, such as pinch, bounce, twist, and fold the aligner. Soak the aligner in hot water to check temperature resistance. Expose it to UV and dip in liquids to check stain resistance. We made a short video to better demonstrate 10 steps. This concludes the topic for today. Hopefully, my sharing is helpful for you to choose a proper aligner material and produce aligners with controlled performances. If you have any questions or learnings to share with us, please contact our sales managers or drop us emails. Thank you very much for your watching. Goodbye.